All right, so what is the value of sine 210? What is alpha and beta you assume? Okay, for this example, we can assume alpha is 180, beta is 30, 210, and then if you write the formula for sine alpha times cos beta plus cos alpha times sine beta, right? Did I write the right formula? And then you just plug alpha and beta here, which is sine 180 degree times cosine 30 degree plus cosine 180 degree times sine 30 degree. Now, sine 180, what is the value of sine 180? 0. All the 90 180s are zeros for sine. So 0 times cos 30 degree plus cos 180 is -1, and sine 30 is half. So here you go, your value is -half. We are trying all these different kind of degrees because at this point, when we'll be working with power reducing formulas from section 5.3, we will have to deal with the trigonometric function with degree larger than 90s. So anytime you have anything larger than 90, if you don't remember, this is one option of getting those angles. I'm saying getting the trigonometric function ratios for those angles. So the power reducing formula was, remember yesterday we were discussing about the double angle formula. Today we'll be talking about the power reducing formulas, half angle formulas, and all of these are trigonometric formulas for including all the trigonometric functions, especially sine, cosine, and tangent. Let's see. These are all the formulas we have. We don't have it, right? All the formulas. You have the formulas? Oh, okay. Sure. Okay. All right. So, power reducing formulas here. I think we have all the power reducing formulas at the last page. If you look at the power reducing formulas, there are 3 power reducing formulas for sine, cosine, and tangent. If you look at the formulas, the reason they are called power reducing, if you look at the right side of the formula, you see the power is reduced by 2. Basically, in the left side you have sine square, in the right side you have cosines for both sine and cosine square, and for tangent still you have cosine theta in the right side. So you are power reduced right now. So how you can apply these formulas? Remember, at this point we are just learning different kind of trigonometric formulas, and all those formulas are basically coming from the trigonometric identities you have if you from the previous sections. If you remember, let me show you the first one just to make sure that we understand that how these formulas are coming into the picture. You may remember that for cosine 2 theta in the yesterday we were looking at the formula for the cosine 2 theta was 1 minus 2 sine squared theta, and this is one of our double angle formula, right? Because you see in the left side the angle is double, in the right side the angle is half. So that was one of our double angle formula, one of the formulas for cosine 2 theta, because you remember for the cosine 2 theta we have the same formula but 3 different forms we had. So this is one of the form, and if you try to modify this formula, let's say you want to see what is the sine squared theta from here. What do you want to do? You want to probably add one, subtract one both sides, or maybe let's say you want to switch the sides of these two to adjust it a little bit better. So when you do this, you know that when you change the side, their signs get changed. So this becomes positive. So it will be 2 sine squared theta equals to 1 minus cosine 2 theta. And then if you divide both sides by 2, you get sine squared theta is 1 minus cosine 2 theta divided by 2. Now the reason I wanted to show you this, because we don't have to do all these derivations, but I wanted to show you all of this just to make sure that we understand that none of these formulas are like fundamentally new formulas. Those are some kind of derived formulas we are getting from the previous sections and the previous formulas. As you see here, so the first one I just tried to show you, and all the formulas can be shown like that or can be derived from the previous sections. Now, but still they are worth to know, because in this form, because they are like different forms of the old formulas, but they are still worth to know, because you will be playing around with these formulas to verify different identities, and most importantly, remember the last class, as I said, that we verified some of the identities, and I said that one of the important part that we look at is, in case of the double angle formulas, that what is the angle right now, and based on that we apply the formula, because we know that every time we apply the formula the angle will be half. Look at the first line here, first line in the left side. If you look at that, cosine 2 theta equals to 1 minus sine squared theta. So one of the important thing you may realize that the theta is getting half, because in the left side the angle is 2 theta, but the right side theta is only just 2 theta by theta, which is theta. And in these formulas, one of the important thing is, if you want to reduce the power, this is one of the choice you might have, because you see in the right side your power is reduced by half. So how we can, at this point we are just learning those formulas, and we will be doing some specific identities where we only need these formulas, but at some point when you will be working with the trigonometric identities, you may have to choose formulas from everywhere based on what you exactly need. You might need like power reducing formula, you might need double angle formula, you might need half angle formula. We did not cover the half angle formula yet, but I'm saying based on what you need, you will be able to choose different formulas from different places. But right now we are just learning some formulas, and we are just trying to see how we can apply these formulas to do some of those things like here. For an example, this question, write an equivalent expression for sine to the power 4x. Now remember, as we are talking about the reduction in the power, and you see here the sine to the power 4, it has a huge power which is like to the power 4. Okay. Now the question is saying that can you write sine to the power 4x in an equivalent expression that does not contain powers of trigonometric functions greater than 1. What does it mean? You will be writing sine to the power 4x in another expression where there will be trigonometric functions. There may be sine, cosine, tangent, something else, but none of the trigonometric functions will have power more than 1. So they will look like cosine theta, they will look like sine theta, they will look like tangent theta, but no tangent square, no sine square, no sine cube, no sine to the power 4. Can we do this? See, we are trying to show you that if you have such a problem in future, in some case, these are the remedies you have. Because look at the left side. This is your formula for this one, because at this point you don't care about the angles. You don't care that how the angles will be changing, because if you see here, if you have something to the power square, for example sine square here, if you go to the right side, the power is reduced but the angle is getting doubled. But look at the question here. it doesn't care about angle. It's not talking about what the angle will be. Okay, it may be double, it may be something else, but only thing we want is we don't want any power except 1. Everything should be in terms of to the power 1. Now, as we do every time that we just give you the option. So let me give you little hints and see whether you can proceed from there, and then I'll help later. Now, your formula is there, which is sine squared theta. Now, that will be your formula. Let me give you little hints that how you can proceed, then we'll give you little time so that you can try first, and then I'll help you for sure. Now here, your expression is at this point sine to the power 4x. Now, sine to the power 4x can be written as sine square x whole square, right? Whenever you have this, you can of course apply sine square x, because you see the formula for sine square theta. I'm saying theta is x right now. So you can right away apply that formula and see what you get from there. Okay, that's one of the clue. And remember, there are other. This is the formula for sine square theta. We have 2 more formulas, right? One is for cosine square theta in this part of the section, which is 1 plus cosine 2 theta divided by 2, right? And another one is the tangent squared theta, which is 1 minus cosine 2 theta over 1 plus cosine 2 theta. In this part of the section, we'll be talking about only these 3 formula, number 1, number 2, number 3. Now, using these 3 formulas, now first one you can probably see it right away, right? Because that's probably this one, right? Because sine square whole square, so definitely you'll be applying these. And once you apply these, see what you come up with. If you still have something to the power more than 1, you will have to choose something from here. You see what I'm saying? So these are the hints. Let's see how far you can go with this. Alright, so any good luck? Anyone has the answer? Now, let me show you what we want to do. First of all, remember, our intention is no power except 1, right? So we'll be applying the power reducing formulas again and again until we do not see that point. Now, the first one was here. We just, we can just directly apply the formula from there, which is the 1 minus cosine 2x over 2 whole square. If we apply it, your denominator is going to be 4, 2 square. And in the numerator, how you do? You just apply, you can apply the formula, or you can, formula means a minus b whole square formula, or you can just multiply 1 minus cos twice x times 1 minus cos twice x. Then you will end up with something like this. 1 minus 2 cosine twice x plus cosine square twice x. You can just multiply 1 minus cosine twice x times 1 minus cosine twice x. Now, for now, what you can do is you can divide everything by 4 to see which part of the expression need to be taken care of. Now here, if you divide everything by 4, the first one will be 1 over 4, right? Middle term is going to be cosine twice x divided by 2, because there is a 2 and we are dividing it by 4. So 2 and 4 get cancelled. And the last one, it will have cosine, maybe I can write in a little bit different form. Maybe I can write it 1 over 4 times cosine squared twice x. Now, at this point, what do you see? Still there is an issue here, right? See, I'm just trying to show you how where you want to work still, because this part is not done yet, because still you have to the power 2, right? There is a square which is which you don't want, and you want to get rid of that square. Simple formula. U formula is there. So we'll just apply that formula here. Okay. For the formula, at this point, in the formula we have theta, but our theta is what? 2x. Right? Let's apply the formula. Remaining part is fine. We don't want to touch any part here because they are just fine, because everything is with power 1. It's a constant, is with power 1, so it's fine. Now let's see what do we get next. 1 over 4 minus half cosine 2x, which is exactly as it is, plus 1 over 4 times, let's write the formula for cosine twice cosine squared 2x. Before I write the formula, I'm just trying to copy the formula from there. 1 plus cosine 4x. You know, look at the right side. The theta is getting doubled, right? At this point, the theta is 2x. It's getting doubled, which is 4x, divided by 2. It's a little bit better right now, I think. What do you get? 1 over 4 minus half cosine 2x, because the rest is algebra for us. So is 1 over 8 plus 1 over 8 cosine 4x. Now at this point, you see, we are almost done. The only thing is we have little algebra left, because we can do little algebra between these two. 1 over 4 plus 1 over 8. That's it. How much it will be? 3 over 8, right? If you add 1 over 4 plus 1 over 8, it will be 3 over 8, and then rest is same, because at this point we don't have anything which has power more than 1, because it has power 1. The last expression has power 1, and the other part is constant, which has power to the power 0 for cosine or sine or whatever the trigonometric functions you have. What is the question?
1/4 taken out of the
Here?
cosine.
Here?
Yeah, right there.
I'm not taking.
You bring it down.
I'm not taking it out. I'm just multiplying with this.
Okay.
So,
So
if,
shouldn't it be 1/8 cosine 4x?
yeah, that's what I wrote.
And then why do you have the 1/8 there?
That's for this one. Because for an okay, yeah. So let's see. Let me show you in a different way. Just look at it, because that's a part of algebra. That's why I try to skip those discussions, because I know that probably some of you already exposed to those. So let's take this bracket out. What happens if you just don't write 1 over 4 here? This becomes 1 over 8, right? I'm saying just multiplying 4 by 2, because both are at the denominator position. Now you see that, right? Yeah, maybe because you're just multiplying the denominators and the numerators. So your denominator was 4 there, and denominator is 2 here. It's 8. Now it's 1 over 8 and 1 over 8 times this. And then when you do the math between these two, 1 over 4 and 1 over 8, remember this will be 3 over 8, right? So it will be 3 over 8 minus these plus these. But that's algebra. That's like tweaking and twisting with the algebraic expression. But remember what we wanted to do. We just wanted an expression where no power except 1 or lesser. Lesser is fine, but not larger. And we keep applying the formulas here, because we wanted to apply the formula here because we know that we still want to get rid of this square. Okay. Now, these formulas will really help you when you want some kind of expression from one trigonometric form to another trigonometric form. You want some kind of form change, and you exactly know what you want to get rid of. Let's say you want to get rid of power, you want to get rid of some angle, or you want to double something, you want to make it half something. In those cases, these formulas will work, but you will have to know which formula to apply when. Okay? And this book is really great, because it's basically classifying all the formulas for you. It's not giving you like, okay, look at this. These are the list of all the trigonometric functions or formulas. Not like that. We are just classifying the formulas for you so that you know that what formulas does what. And also, as I said before, all these formulas are not fundamentally new formulas. They are old formulas, but we are just writing the same formulas, twisting and tweaking the old ones. They look new, but they are old formulas. Any question here? You have question? Simply, okay. Any question here? Now, let's move on. Remember, we'll come back to these formulas again because at some point in the later sections, we'll need these formulas again. And that's why we're just introducing these formulas and showing you the applications of these. Now, these formulas are called half-angle formulas. Again, as I said, these are not new. Again, they are again the same formulas. Okay. Now, how that is same? Let's say the first one. How that formula is same? Did you find any? Okay, let me give you little hints because we are not here to derive the formula, but since I mentioned that none of these formulas are new, they are old derivations, so we just wanted to make some connection. Let's say the first one and this one. Let's see. Look at this one, number 1 here. This is from the previous part of the discussion, right? And that's the new formula. Do you see any correlation between those two? I gave you some clue. Do you see anything here? Now, let me give you some more clue. Look at this. If you just try to write sine theta from here, this will be square root, right? This is the sine square is this. Sine theta will be the square root of 1 minus cosine 2 theta divided by 2, right? Look at that. And also, look at the relation between two angles. Whatever the angle you have in the right side, the left side angle is half. We exactly have the same situation there. Look at the right side angle, that is alpha. Left side angle, alpha by 2. Again, that's not new. It's just like giving the same drink but in a new bottle. But there is a new purpose here. Purpose is, these formulas are called half angles because they are written for half angle, because you see in the left side that's half, and the right side that's double. Okay. And also, one of the things that probably you will notice, because you know that whenever you are doing a square root, you always get plus and minus sign. And these formulas also have plus and minus signs. But this doesn't mean that you will have plus and minus for every single formula you apply. The reason the plus and minus mentioned here because of the quadrant issue. Because we know that whenever you are in different quadrant, based on that, sine, cosine, and tangent will have different signs. For an example, let's say if you are talking about some alpha by 2, which is in quadrant 3, then for sine, we'll take negative. Because we know that the quadrant 3, sine is negative. Cosine is also negative. Only the tangent is positive in the cosine 3. So that's exactly what it meant by plus minus. Don't assume that we have plus and minus both. The reason we assume plus minus because it may be plus, may be minus based on the quadrant. If you see the last trigonometric functions here, that's exactly similar to this one. Nothing new. Because if you try to write tangent theta from here, it will be square root, right? It will be square root. And look at the angle relation. Left side, whatever the angle you have, right side the angle is doubled. Or whatever the angle you have in the right side, this is half, right? Same is there. Look at the angle in the right side. Look at the angle in the left side, that's half. See, it's exactly the same formulas. They are just showing you the different forms of the formula. Don't get overwhelmed by so many formulas. It's not so many. It's just again the same formulas. We are just showing you in different forms. And interesting is, tangent can be also written in this form. Interesting is that is also not new. Let me show you some example. One example, just to make sure again to convince you that that's not new. You can write the same formula in different forms. We don't have to know the derivation, but that might make you a little bit interested to know that there are not too many formulas, but same formulas we are representing in different forms. Let me write that formula for you first here. Let's say tan alpha equals to square root 1 minus cosine of this alpha by 2. Let's write alpha here. 1 minus cos alpha, 1 plus cosine alpha. Okay. Now, for time being, I just got rid of plus minus because we know that the plus minus has a different purpose. We know it. It's based on the quadrant. Let's ignore it for a while. Now, as you see here, we have some different forms of the formula. Now, how this formula form come into the picture? Let me show you an example. Okay, now, let's say I multiply this. You know that if you have any kind of fraction, you can always multiply the fraction by something like this. What I did, I multiplied both numerator and denominator by the same thing, right? You can always multiply the denominator and numerator by the same number. We know that, right? For any fraction, doesn't matter what it is. You can always multiply the denominator and numerator by the same number. Look at this. It's the same, right? Now, what happens after this? Whenever you are multiplying the square root 1 minus cos alpha times square root 1 minus cos alpha, it becomes something like this. 1 minus cosine alpha square root whole square. And then this one, what happens? What happens here? This is something like this. Under the square root, you are multiplying 1 plus cosine of alpha times 1 minus cosine alpha. It becomes 1 minus cosine square alpha. Basically, it's just raw multiplication. Okay, just raw multiplication. Now, what is next? Here, the square root and a
Square get cancelled, right? This square root is basically half, to the power half, technically.
So if that gets cancelled, this becomes only 1 minus cosine alpha, right? And what happens with this? Square root of 1 minus cos square. What is that? Remember the identity? The sine square, right? That becomes sine square. 1 minus cosine square equals to sine square, right? We probably know it for sure right now, since we are doing the homework. Because that's probably the first formula, first identity we want to know. Now, here, sine square and then the square root get cancelled. Then if you just cancel these two, look at the first form. Do you see it? So again, it's not new. As I said, that is again the same formula we are writing in different forms just to convince you. And this one, you will get the second form if you multiply both numerator and denominator by plus. 1 plus cosine alpha and 1 plus square root of 1 plus cosine alpha. So again, we just know it, but we will be applying the formulas as we need. So at this point, we have all the formulas written under the half angle formula listed in page number 4. So again, these are not new formulas, same formulas, but so make sure when you are browsing the slide, check the study tip, because sometimes they want to tell you some common mistakes that we make. So, okay, here is the reason why we started with the, remember I said at the beginning that, can you find sine 210 at the beginning? This is where we need the sine 210 right now. Now, here you have to find sine 105 degree. Okay. Now, how can you use our formulas for the sine alpha, cosine alpha, okay, alpha by 2 for this? Let me show you an example. Here, our angle is 105 degree. Okay. Now, 105. See, we know the alpha plus beta formulas, right? But let's see. But you can always get the 105 from there, because you can add 60 plus 45, which makes 105. So and then you get 105. But if you have to apply, if you want to apply this is another way of doing it. You can also do this. Just write 105 degree, and then write sine 210 degree divided by 2. That's how you bring alpha by 2 into picture. Now what is alpha here? What is alpha here? 210, right? The rest is just formula. Apply the formula now. What is the formula? Just go back to the formula page. We have the formula listed in the back of the slides, back of the formula list. Let's apply the first formula. And also careful about this. This is 210. What is the quadrant? What quadrant it is? First, second, third, fourth. It's third quadrant, right? Because it's more than 120, less than 270, which is third quadrant. What is sign? Positive, negative? It must be negative. So, when you apply the formula, make sure you start with a negative sign, because that's negative, we know it, right? And then just apply the formula. 1 minus cosine alpha is 210, and then divided by 2. Now, before you proceed, you will need the value of cosine 210 here. You will need the value of cosine 210 here. You can get it from calculator, or you can also use the sine alpha plus beta the cosine alpha plus beta formula, where alpha can be 180, beta can be 30. That's how you can get cosine 210. If you are done, you can also try these, because this is the same example, but now we are doing the same thing for tangent. So you will apply the formula for tangent. Your x is going to be 210. So because you will be applying the formula, so it will be 210. This is tangent 210 by 2, so the alpha is 210. These are easy questions, because if you see this question, all you need to do is just apply the formula. But sometimes you might have some trouble finding the angles. So one option is just use a calculator, because you can just use the calculator. But if you really want to play around this one and you want to see that how it come into the picture, you can just apply the alpha plus beta formula. This I'm saying. For example, for cosine 210, you can write cosine 180 plus 30, then apply the cosine. Because here the alpha is, for that formula, alpha is 180, beta is 30. You can find it. So you have the alpha beta formula for sine, cosine, and cosine, so you can always do that. And you will never need for tangent, because even the tangent formula, tangent alpha plus 2, alpha divided by 2 formula, is basically given in terms of cosine. So all you need is the cosine alpha plus beta formula whenever you need this. Okay, here we have all the known formulas. These are summary of all the formulas what we have seen in this chapter. Okay, at a glance. At the beginning, we started with the some of the formulas. Okay, now remember the first couple of formulas we looked at in the previous section, which were the formulas where sine two angles. One angle is represented as a sum or difference of two other angles, and then we calculate those. And then starting from the double angle formula, power reducing formula, all the way to the half angle formula we covered in these sections. So you have all the list of formulas, but remember, you understand when to apply what. That's the important part. You will have access to all the formulas. I gave you all the formulas, and you can bring all the formulas. You can make all different kind of comments there, unless you just solve some example. You can, if you want, you can make some comments there as well and bring it to the test. But make sure you understand what to apply when. What do you need when? Because just again, the first couple of formulas for alphas and betas, those you need when you have some angles like this. For an example, you have an angle like 210. You can break it down like 180 plus 30. Make one alpha and another beta. Apply the formula, get the value. Or in the second one, here, you'll need the formula when you are trying to make the angle into half. Because if you look at these formulas, in all of these formulas, in the right side, you see the angle is getting half. whatever angle you have in the right side, the angle is half. So anytime you need to do that, that's your option. In the next ones, everywhere you are reducing the power by half basically. So right side, whatever the power you have. In the next ones, you have half angle in the left side, double angle in the right side. So based on all these options, you will be able to choose what formulas you will need. Now you have plenty of formulas, and none of the formulas here are fundamentally new formulas. All these are coming from the very basic trigonometric identities that you have learned at the very beginning. Like, remember all those identities where you know the relations between the trigonometric functions, between sine and cosine, between the inverse ones, tangent, cotangent. Most of those are coming from there. Most of those. So none of these are basically fundamentally new formulas. None of these. Any question here? So there are a couple of remaining slides which we have the same questions that we tried. So I like to stop it here, and then we want to move forward, which will be the section 5.5.